Hello, I am N. Praveen Kumar, working as Assistant Professor of Mathematics. Welcome to Numerical Methods and Integral Transform course. The last session we discussed about the introduction of interpolation and real-time usage and real-time applications of interpolation. So, today lecture we are going to be discuss about how we are going to be find the unknown values using of this finite differences concept. So, basically the finite differences we have the finite differences. There are three type of finite differences exist basically. So, the first one is forward differences, the second one central differences, third one is backward differences. So, if you have some data points, so let us assume the data points x0, x1, so on xn. So, respective y values y0, y1, so on yn. So, when this differences, finite differences we are going to be used to find the unknown value, so which lies inside from the known data points. So, if this to find this unknown value, let us assume if it is located around beginning of the table. So, to around beginning of the table, to evaluate this value, we can use the forward differences concept and that respective table and that respective formula we are going to be used. If it is located around middle, so it is located middle of the table, around middle of the table, we are going to be use the central differences concept. So, if it is located around end of the table, so we are going to be use the backward differences concept. So, there are three types. The first one is located beginning, the central differences located in the middle. So, backward located end of the table we are going to be use. So, we are going to be see in this lecture how we are going to be construct that respective tables of each case we are going to be discuss. So, forward difference table. So, this basically forward differences is denoted by, so there is a symbol which we are going to be use, this delta. So, this delta, capital delta, simply we can call it as delta. So, this operator we can call it as a forward operator. So, this operator we can call it as forward operator. So, from the provided data, how we are going to be construct the difference table we will see today. So, let us assuming some points in this. I am assuming x0, x1, x2, x3 respective function values y0, y1, y2, y3. So, the forward differences we are going to be use if the point is located beginning of the table. So, we are going to be find the differences, the name itself saying differences we are finding. So, this differences we are going to be write y1 minus y0, always we need to be take the second value minus first value. Same way, second value minus first value, we need to be find the difference y2 minus y1, second value minus first value y3 minus y2. So, these differences we can denote in the forward delta. So, how we are going to be give the notations for this delta in these two, which one exists the first, that we are denoting as here delta followed by in these two the first value. So, similar way these two differences. So, these two differences delta in these two, this is called the first value, so that we denote delta y1. So, like in these two delta y2. So, this is called the first order differences we are calculating. Similar way differences of these differences we can call it as second order differences. So, second order differences will be denoted as delta square. So, difference of the first order differences we can call it as second order differences. So, difference of these two. So, therefore, we denote it as delta square y naught. So just we trying to write the differences between these middle of these values, so that will be understood easily. So we are finding the differences of these two values, delta y2 minus delta y1, so which is equal to delta square y1. So similarly we continue this table till the differences exist, in the sense the last value, single value exists. So we can stop the process. Difference of these second order differences we can call it as third order differences. So that will be denoted as delta q y naught. So like this we are going to be construct the forward difference table. The next stage is using of this table, and we use the formula. In that formula we substitute these respective values. So we are going to be evaluate the value which lies around beginning of the table. That is what we are going to be use of this forward difference table. So the second concept is backward differences. As I said, the backward differences which we are going to be use, the point is located around end of the table. So around end of the table. So this backward differences we are denoting as del. So this notation we can call it as del, or we can call it as nabla. So we can call it as del or nabla. So located around end of the table, we are going to be use the concept as backward differences. So backward differences, and that differences considering the same points, and we are going to be construct the differences table. So same way, just I am considering few points to construct the differences table. So backward differences table. So to understand clearly, just I am considering few points, x0, x1, x2, something x3. So respective function values. So it may be the y values, we can call it as functional values. It may be the values, we can also call it as experimental values. It may, you can also call it as output values, right. So that respective function values or output values or experimental values will be given like this. If the value is located around the end of the table, so which lies inside the given set, we are going to be use this backward differences table. So this we are going to be denoted by del. So this name we can call it as del or nabla. So the first order differences, same like the previous slide we discussed about the forward differences, same way here also we are going to be find the differences for between the two values. So first value, second value minus first value. So here the difference is same, but we are notating differently. That is what the difference between the forward and backward. So if you observe the previous one, differences we are considering the same. So here also we are considering the differences is same. So second value minus first value. So y3 minus y2, difference is same, but the same difference we need to be noted differently in the forward, in the backward as well. So backward differences we denote. So previously the forward we consider this as y naught, but where the notation is backward, so that's what we will be take the second value in these. So this notation is del y1. So in these two, obviously del second value y2. So difference of these, just we consider del y2. So these differences we can call it as first order backward differences. So similarly, just we can find the second order differences. Difference of the first order differences. So del y2 minus del y1. So which can be written as del square. So del square y2. So difference of these two. So del y3 minus del y2, which is equal to del square y3. So difference of the first order differences we can call it as second order differences. So similar way, there is obviously 4 values are there. So for n is equal to number of observations 4. So therefore obviously del power n minus 1 order table you are going to be exist. So n is equal to 4. So n is equal to 4 if you substitute. So del cube. So del cube table it is going to be exist. So simple, remember this technique. So difference of the second order differences del square y3 minus del square y2. So we are going to be get del cube y3. So like this we are going to be find the first and second third order differences. If you observe clearly, so the backward you are going to be have the values, the last values will not be change anything. Since we said this we are going to be use the location is end of the table. That's what more moving average and weightage we are going to be consider for the end value. That is what the table is like this. We are going to be construct the backward difference table like this way. So the third concept is central differences. The central differences basically we are going to be evaluate or find the unknown value if it is located middle of the table. So as I said the first slide, location, the points are something x1, x2, so on xn, that respective values, function values are experimental values, y0, y1, so on yn. If it is located middle of the table, we are going to be use the central differences concept to evaluate that unknown value which lies inside the given set of tabular points. Now we will see how we are going to be construct the central differences table. So central differences table, so we have some data points. So central differences is denoted by, so this we can call it as small delta. So this notation we can call it as small delta. So using of this small delta we are going to be notate. So right, so we are going to be consider few data points x, y. So using of this x, y we are going to be consider few points. Based on the few points we are going to be construct the central differences table. So let us assume some data points x0, x1, x2, x3. So respective functional values or experimental values will be considered like this. So differences is same, like what way we constructed the forward and backward, differences same. So y1 minus y0, y2 minus y1, y3 minus y2, differences same as previously said, notation is different. So small delta is the first order central differences. So this we are going to be denote as small delta, taking the averages of these particular suffixes. Look at the y0 plus y1, just we need to be take the suffixes average. So this suffix is 0 plus 1 by 2. So therefore the notation we are going to be use as delta y suffix 1 by 2. So simply call it as small delta y 1 by 2. Similarly, so here these two values we take the average 1 plus 2 by 2. So it is 3 by 2. So these differences we denote as small delta y 3 by 2. So like we need to be find the last difference even. So y3 minus y2 is equal to, so again take the average of these two. So 2 plus 3 by 2, it is called 5 by 2. So the notation small delta y 5 by 2. So this is, we can call it as first order central differences. So similarly the second order differences, difference of these two, as I said, small delta y 3 by 2 minus small delta y 1 by 2. So these differences, as I said, average of these two. So 1 by 2 plus 3 by 2 divided by 2. So therefore we are going to be get 4 by 4, cancel it, we are going to be get 1. So this is called small delta square y1. So difference of these two, so small delta y by 2 minus small delta y 3 by 2. So if you take the average of this 5 by 2 plus 3 by 2 by 2, so this we are going to be get 8 by 4, which is 2. So to remember easily, there will be a simple trick. If you observe the observation here, so this actually average of these two, average of these two, average of these two. Again we are taking the average of these two. Obviously we are going to be get the middle point here. That is what the trick, we need to be remember this. So here also this is called average of these two. So this value or notation we can call it as average of these two. Again we are taking the average of these two. So the mid value or center value is going to be act as here. That is the trick we need to be remember. So similarly, just we have same as I said the same trick. There are 4 observations. So delta power n minus 1th order is going to be exist in this case. So n is equal to 4, 4 minus 3. So obviously n minus 1th order. So this is called delta square y2 minus delta square y1. So therefore difference of these two, delta cube. So again taking the average as I said, the middle value 3 by 2, just we can write it here, middle value 3 by 2. Like this we are going to be notate the central differences. This is called second order central differences. This is called third order central differences. Like this we are going to be construct the central differences table. So in this lecture we have discussed about different types of differences and interpolating value based on the locating of the points. So if that types of differences as we discussed, forward differences, backward differences, central differences, where based on the locating the point we decided if the point is located beginning of the table, we use the forward differences. If the point is located middle, we can use the central differences. So if the point is located around end of the table, we are going to be use backward differences. So this is what we discussed in this session. So the next session we are going to be discuss how we are going to be find the values if it is located beginning, if it is located middle, if it is located end of the table, that we are going to be discuss in the next session. Thank you.